Hi, we're going to learn how to construct what are known as ray diagrams. Ray diagrams are a way of visualizing how images are created by lenses. We're going to start off with a converging lens, and we are going to draw the image of an object that is inside the focal point. So I'm going to take my object and I'm going to try to draw it here so it's inside the focal length. And let's put a little tip on it so we know it's an arrow. Now the secret to this is you really only need two rays to make an image. I'm going to draw a ray that starts at the tip and comes in parallel to the principal axis, something like that. Now the ray that comes in parallel like that, when it's done going through the lens, is going to wind up coming out through the focal point. Okay, something like that. So that's my ray, comes in parallel and out through the focal point. Now the reason I know it bends in is because this is a converging lens. Now the second ray I'm going to draw is going to start at the same spot, and it's going to pass right through the middle of the lens and not bend at all. This is because, again, if you go through the middle, essentially you're going to get equal refraction on both sides, and you're going to come out parallel to where you started. Now, these outgoing rays, I'm going to put some tips on them so we know that they're outgoing rays, are not converging on this side of the lens. So how do we know where they converge? And the answer is they converge back on the other side of the lens. So I'm going to change the color here, and I'm going to draw some lines that go back something like this and something like this. And that's good enough. And the image that I'm going to create is going to be where those two converge. And we'll see something along the lines of this. Put a little hat on it, and that's my image. Now this kind of confirms what we saw before. If you take an object and put it inside the focal length of a converging lens, you're going to get an image that is upright, enlarged, and virtual. And we only needed two rays to do it. The next image we're going to create is one where you've got your object past the focal point, but not too far past the focal point. So I'm going to start off by drawing an object out here, and I'm going to send some light rays in. So first I'm going to send one in that is parallel to the principal axis, and I'm just going to go to the center of the lens, somewhere right about there. And then I'm going to pass again out through the focal point. Okay, something like that. And I'm going to draw a little arrow on the end so we see the direction that the rays are moving. The second one I'm going to make, again, is right through the middle. There we go. Put a little arrow tip. We see the point of convergence now is out here. I'm going to draw an image, and I'm going to make this image right out here and put a little arrow on it. And again, we confirm what we saw in the previous video. This is inverted, this is enlarged, and it's real. Now there's a reason that it's enlarged, and the reason is because we've actually put this in a special place. It's between the focal point and a point that's twice that distance. So I'm gonna, if I call this F for the focal length, out here is 2F. When you place an object between F and 2F, you're going to get this enlarged real and inverted image. The last type of image I can create with a converging lens is when I put the object out beyond two focal lengths. So I'm going to draw an object, put it out here, and create my rays. Once again, first ray is going to go in parallel to the principal axis, right there, and out through focal point. Now, we know from the last video that there is a double refraction that goes on in here. We're not drawing that. We're doing something that is a little more simplified, and it works just fine. So if you noticed that from the last video that I'm not drawing the double refraction, that's because it's not terribly necessary for this exercise. So now I'm going to make my other one, the one that comes right through the middle. We are going to see that the convergence is happening at this point now. And here's my image. The only difference between this and the one where we placed it between the focal point and two focal points is that it's now reduced. So it's inverted, reduced, and real. And those are the three types of images you can make with a converging lens. All right, now for the diverging lens. So first thing I'm going to do is I'm going to make an object. I'm going to make it way out here. I'm going to start way out here, draw myself an arrow, and let's construct our diagram. Okay, first ray in parallel. Go to the center and get it lined up something like that. And now here's the difference. Okay, before we go out and through the focal length, or through the focal point. But this is not a converging lens, it's a diverging lens. So what am I going to do? What I'm going to do is take this ray and go and diverge away from this focal point. So I'm going to pass this way. Okay, I'm making it blue just so we can see a little bit easier what's going on. So the ray actually comes in from here and then diverges out this way. There we go, something like that. So it comes in parallel and diverges out in a way. The second ray is a lot easier. The second ray, we're going to go right through the middle of the lens like we got to do before. Okay, and there it is. Now, if we look and see where these outgoing rays, this one and this one, converge, they converge back here. And my image is going to be this little guy right there. Okay, just a tiny little image that is upright, reduced, and virtual. This is the only kind of image you can make. The question might be, well, what happens when I do move that? And I will show you that if we do move this in a little closer, let's say we take our object and I'm going to move it in closer. I'm going to keep it the same height, but I'm going to move it closer. I'm going to draw the rays. Well, this ray is already drawn for me. It comes in parallel and goes out away from the focus. Okay. The second ray, the one that passes right through the center, the biggest difference is it just intersects with this ray in a different spot. So when I draw this new image, which I'm going to make green this time, the only real difference is that it's a little taller. Okay, but it has the exact same image characteristics. It's upright, virtual, and reduced. Thanks for joining me.